Welcome back, dear students, to this channel, this Awesome channel. Today, we are going to conclude with the AGT hash tables by looking at what we call collisions when it comes to hash table and how we can resolve this problem of collision. Without wasting so much time, let us dive into the topic. Collisions. Collision occurs when the hash function maps two different keys to the same location, that is, producing the same index for two different keys. Obviously, two records cannot be stored in the same location. So this is what we call collision when it comes to hash tables, whereby our hash function that we are using produces the same index for two different keys. And obviously, this cannot be done because when we shall be performing searching, we might have some problems. Collision resolution techniques are used to solve the problem of collision in hash tables. We have two methods for resolving collision issues. Number one, we have the separate chaining, also known as closed addressing. Collision can be handled with the use of linked list. Again, we are coming back to linked list. Let me ask this question: is linked list static or dynamic? If you say dynamic, then you are right. Instead of storing the actual data in the hash table, we store a pointer to a location where the data is stored. Each data item is stored as a node with three attributes: the key value, the data, a pointer to the next node. Remember that when we were talking about linked list, we saw that each node contains just the data it has to store and the pointer to the next node. But when we are using a pointer in a hash table, it contains three attributes, that is the key value, the data, because the key value is what we are going to use when performing searching, the data that is supposed to be stored, and a pointer to the next node in such a way that if our hash function produces the same index for two different keys, at least they can be related. The first value to be stored will have a null pointer as it is the only item in the list. When there is a collision, the pointer for the first node at that location will be updated to point to the new node. So when we have one item at a particular location, its pointer is null because it's the only one there. But when we have another data element that is supposed to be stored at the same index, that our first element who has as pointer null will be updated in such a way that its pointer will point to the location of that other data item stored at the same location. This will create a chain of nodes whose keys resolve to the same index, that what we call separate chaining. As example, we have this diagram. As you can see, these are the different values we want to store. For our hash function, we are seeing that Anna, Dave, and Leo are having the same value, which is 0. That the hash function produce the same index for them. And so what happened? First thing, Anna is stored with a key. That is, our key is Anna, the value 105. And now its pointer is pointing to the next value, which is Dave, because Dave is also stored, has the same index. Dave also, his pointer is pointing to the next one, which is Leo, because they still have the same index. And since Leo is the last item in that particular index, its pointer is null. When you look at this particular one, Evan is the only one stored at index 2, so its pointer is null, which is the same thing with Bell. But when it comes to Max, its pointer goes to Alice because they are having the same index. And since Alice is the last item at index 6, her pointer is null, provided she's a female. So that is how we are using a linked list to resolve collision in a hash table. As you can see, very easy. The other method is what we call closed hashing, also known as open addressing. Once a collision takes place, open addressing computes new positions using a probe sequence, and the next record is stored in that position. So what are we having here? When I am storing my data in a hash table, if my hash function produces an index that is already occupied, then I am going to update that my hash function in such a way that it produces a new location that is free, and it keeps on repeating until it gets a free location, because my update and the next location we have is still occupied. So we keep on producing new location until we have the first location, which is empty. In this technique, when a value is generated and occupied index, we follow an algorithm to search for a vacant index in order to store this value. Open addressing technique can be implemented using linear probing, quadratic probing, double hashing, and rehashing. So those are the four different methods we have under closed hashing. But we are going to focus only on linear probing. In this technique, if a value is already stored at a location generated by f key, that is our hash function, then the following hash function is used to resolve the collision. That is, f key of I will be equals to what? F key plus I mod m. That's what we have. In other words, if a location is occupied, we look for the next free location and we store the value. That's how linear probing works. And it is the simplest approach to resolve a collision. Let us understand this by solving a question. The Southwest Regional Mock 2022, question 7, sub 1 and sub 2. The questions are there. The first one is bringing us back to algorithms, whereby we are asked to define a counting loop, given the three actions that a counting loop perform using the counter variable. And the B part, which is very interesting, says when a loop is used to compute the sum of a set of numbers, why is it critical that an accumulator variable for the sum be properly initialized? What must the initial value be of the accumulator be? Dear students, if you did not watch the videos on the algorithm, I will advise you to go and do so because it is very detailed and contains everything that you need in order to excel in the chapter for Computer Science Advanced Level 795. Okay, the C part says state two main difference between a while loop and a repeat loop. This first part takes 6 marks, and frankly speaking, these questions were all answered under the explanation of the chapter algorithms. But our main focus is the sub-2, which says using the hash function h key is equals to key modulo 9, insert in the order given the keys 5, 29, 20, 0, 27, and 18 into a hash table of size 9. Use linear probing to handle collisions. 6 marks, dear students. So only question 7I and sub 2 together takes 12 marks. Very important. Solution. The A part. A counting loop, also known as a count control loop, is a loop that repeats a specific number of times. That is, the number of iterations is known before we start the execution of the body in the loop. That we call a counting loop. Actions performed on the counter variable are initialize, testing, and updating. For I equals to 0, that's the initialization. I should be less than a particular value or greater than a particular value, that's the testing. And now updating. After an iteration, is our counter incrementing or decrementing? Incrementing or decrementing by what value? That's what we call the updating. So those are the three actions performed on a counter variable: the initialization, the testing, and the updating. B. If the accumulator is not properly initialized, it will not contain the correct value when the loop finishes. The initial value of the accumulator must be 0. And this is the n time I am repeating this. When it's not only for the for loop, when you have a variable that changes for every iteration of a loop, if it changes through addition, then that variable must be initialized to 0 or initialized to a specific value precise in the problem description. But if it changes through multiplication, it should be initialized to 1 or a value described in the problem. That is it, dear students. The C part, the while loop, there's a difference between while loop and repeat loop. The while loop, the test condition is tested at the beginning of the loop. The repeat loop, the test condition is tested at the end of the loop. There are other examples, and I will advise you, if case you do not watch the video algorithms, to go and watch the playlist. The link will be given in the description of this video in order for you to go and properly watch the playlist under the chapter algorithms. Everything is covered: introduction, representation of algorithms, converting algorithm from one form to the other, dry running algorithms, writing algorithms, searching and sorting algorithms, subroutines, recursive functions. Everything is being treated in the playlist, dear students. Now, the sub 2, which is the most interesting, is another difference. Our hash function is the key modulo 9, And now, since we are using linear probing to handle collisions, our work has to be properly presented. As you can see, that is, I have my key, the hash value this function produces, the collision in case we have a collision, and the probed value, that is, in case there is a collision, what is the value I am providing? As we say here, upon addressing compute new position using a probed sequence. Now, our first value is 5. And 5 mod 9 is equals to 5 because when you take 5 divided by 9, it gives you 0 remainder 5. Remember that modulo returns the remainder, dear students. So now, 5 mod 9 is equals to 5. We see that location 5 is empty, so there is no collision. 5 is stored. The next is 29. 29 mod 9 is 2 because 29 divided by 9 is 9 remainder 2. Position 2 is free, so there is no collision, and 29 is stored at position 2. The next is 20, and 20 mod 9 is 2. But we see that 2 is already occupied. So is there collision? Yes. And if there is a collision, what do? We should use linear probing to handle collision. And as we saw here, once there is collision, to handle it using linear probing, we store the value to the next empty location. Since 2 is empty, the next free location is 3. So that will be the probed value, as you can see, dear students. Because 2 is already occupied, so the next free is 3. So this is where 20 is going to be stored. The next number is 0, and 0 mod 9 is 0. 0 is free, so there is no collision, and we store 0. The next one is 27. 27 mod 9 is 0 because 27 divided by 9 is 3 remainder 0. But index 0 is already occupied, so yes, there is collision. Linear probing, which next position is empty? Sorry, is position 1. So that will be my probe value. So 27 will be stored at 1. The next is 18, and 18 mod 9 is still 0. 0 is occupied. So will there be collision? Yes. What is the next free location after 0? 1, no. Location 2, no. Location 3, no. Location 4, yes. So that will be my probe value. And this is where 18 is going to be stored. And we see that location 6, 7, and 8 are all empty. So guys, this is the hash table. After inserting these different keys with the hash function provided and using linear probing to handle a collision. This is how your work has to be presented in order for you to have all your full marks. That is the key, the hash value, in case there is collision. In case there's a collision, what is going to be the probe value? And from there, you present your hash table with the key and the different values. That is what we have. Sorry, normally here it's supposed to be index and then you have key. But this also goes because I consider this to be the different indices and the value is what is given. But I'm just saying because in the question they say given the keys. So here I'm supposed to have keys and here index. So guys, this is our solution. And remember, as a tradition in the byte family, wherever a particular important part of a topic is done, there must be an exercise for you guys to go and exercise yourself. And the solution is always given in the WhatsApp channel and the Telegram channel every weekend. So, as exercise, the GC of last year, June 2025, question 7 sub 3. I will advise you, dear students, to tackle this question properly and provide your answer in the comment section. You use a dash for empty cells. So I am waiting for your answers in the comment section, dear students. The question says, a hash table consists of an array of size m and a hash function hk that maps a key h to an index in the array where the key is stored. Consider a hash table of size 7 with hash function hk is equal to k modulo m. I'm just helping you, of size m, and then the size is 7, so m here is 7. Insert the keys 26, 17, 19, 13, and 48 into a hash table in the given order. Collisions are handled by linear probing. 5 marks, dear students. This is a cadeau. So we are coming to the end of this video and to the end of hash table. Thanks for watching this video. Remember to like, to subscribe, and to share in order for our community to grow, dear students, because the more we grow, the more we have students who give their different questions which can help other students. Okay, in our next video, we are going to briefly look at graphs, and from there we are going to see the different computing problems we have and the data type or data structure which are proper to use in these different cases. From there, we shall move, as the tradition says, to solve past GC and regional mock question, and a link to an online quiz on the chapter data structure will be provided to you, dear students. Thanks for watching. See you in the next video.